Hello, good morning, everyone. Thank you for being here in this session about DLTs on government. Today we will have 3 presentations, and we are going to start with the blockchain-based carbon trading. Please, feel free. The presentations will last 15 minutes plus 5 minutes for discussion. Okay? Thank you.
Yeah, good morning. Am I audible? Okay, thank you. Okay, good morning, respected audience and our session chair. My name is Alia Sadawi. I'm a PhD candidate at the American University of Sharjah, that is in the United Arab Emirates in the Middle East. My research is about carbon emission trading and how to elevate its performance, especially in terms of governance and smartness. So the outline of my presentation, first I will be introducing the research, then survey the related work and explain the Kyoto Protocol, which I will be coming in the coming slides to explain what is that. Then I will give a glimpse about what is blockchain and smart contract, and I will propose my system, which is based on blockchain, as a solution to carbon trading, and I will show how this system was implemented and tested and evaluating that. After that, I will be concluding. First of all, we all know that countries around the world seek to fulfill economic growth. However, any economic-related activities emit carbon emissions that are harmful for the climate. This is what the 4th assessment report of the Intergovernmental Panel on Climate Change, I quote, said that warming of the climate system is inevitable and is now evident from observations of increases in average global air and ocean temperature, widespread melting of snow and ice, and rising average global sea level. So now we have a clear understanding that there is a problem of climate change that happens due to economic growth because of the emissions of carbon dioxide and other harmful gases. This is where the United Nations interfered, because as we know, a problem that is global requires an action that is also global. And there was a protocol signed in Japan called the Kyoto Protocol after the name of the city, where more than 190 countries signed it in order to minimize the level of emissions of CO2. Now this protocol says that we will be establishing a market-based mechanism called carbon emission trading, based on trading carbon emissions as a commodity. Okay, so it's a cap and trade mechanism where a carbon market is established. The idea is very good, and it was a very good idea to reduce the carbon emissions. However, the way it was implemented faced many issues because there was different types of technologies adopted, different types of practical measures on the ground. So the problem statement says that the existing carbon emission trading is not serving the climate change as it's supposed to be, because it is not an effective and efficient tool. It suffers from challenges such as corruption, manipulation, and non-transparency. It lacks reliable transactions verification and tracking system to provide allowances of double spending. 1 carbon allowances is equal to 1 ton of CO2 emitted in the air. The market of carbon trading is diversified with different policies because there's no one unified market for the whole globe, although the Kyoto Protocol stated that it should be. Also, it's complicated and requires very high costs, and it requires smart digital governance mechanism to control its operation. So we can see that we have a good idea, but it wasn't implemented the right way to be effective. So our research motivation is to address these issues and elevate the system performance, and that consequentially will save the environment. The necessity of an advanced technological backbone for the CET is strongly arising and showing to all researchers. And since blockchain technology emerged and proved itself as a very successful solution for many problems, it fits the platform for CET. Blockchain attracts a lot of attention as an effective way to innovate business processes. It has many characteristics of decentralization, transparency, immutability, privacy, security, and so on and so forth. So the significance of our research is design, implement a blockchain-based carbon emission trading system using smart contract to implement the clauses of the Kyoto Protocol in a way that is automated, smart, transparent, and trusted, with minimized cost and without intervenience of third party and brokers. And this will fulfill the ultimate goal of climate change mitigation and saving the nature. Let's get to know what is blockchain first, because it's mostly associated with cryptocurrency, but actually it's an evolving technology that is formed of network of collaborating nodes, creating a distributed and secure database. One of the definitions that it is a network of software protocols to enable secure transfer of money, asset, and information via the internet without the third-party intermediation. So here we look at the word transfer of assets, transfer of information, not only currency. And this is what makes it valuable and useful for our use case. So it is not only financial transactions, it is used in copyright properties, music, video, stocks, digital assets, anything that could be represented in a digital way. And the most important thing, that the trust is taken from the hands of central authority and puts in the hand of a consensus among nodes that are equal with each other. We use many consensus algorithms in blockchain. One of them is proof of work as the one in Bitcoin, but we know that there's proof of stake and there are any other consensus algorithms where miners are using these algorithms to add blocks to the chain and secure the information, and in return they gain economic incentives or they are rewarded. Smart contracts is one of the informations that are securely embedded in the blockchain in the form of a transaction, and it is automated and it gets triggered whenever a certain preset level of event is reached, and this is where we are using smart contract to write the logic of the treaty of the Kyoto Protocol and make everything automated. So this market-based mechanism is now transferred to the blockchain and will be running automatically without any security breach, without any leakage of privacy information, and without intermediary of third parties. Now, this problem of the Kyoto Protocol was addressed by some researchers, but there wasn't much in the body of knowledge or in the literature that really discussed using blockchain in the field of carbon trading. I found only few researchers which they already provided contributions, but most of the contributions are in the form of frameworks, ideas, and roadmaps. Nothing was given practical. If we look at the limitations, they all did not provide any smart contracts, did not provide any codes, logic, to how to implement these frameworks on the ground. Also, most of the frameworks did not cover the whole process of the Kyoto Protocol. This is the Kyoto Protocol. It says that every emitting party, whatever it is, a company, a factory, will get carbon allowances from the United Nations through their government. These allowances are distributed freely or through auctions. However, each emitter should emit in a way that does not exceed its cap. So if they exceed their cap, they have two solutions. One, to buy allowances from another party that is emitting lower than their cap. This means they have extra allowances. Or they can do it by supporting what they call emission reduction projects or green projects. These projects are endorsed by the United Nations, and mostly they are solar energy, wind farms, etc. So they have shares, and they can offset their extra emissions by supporting these projects. So these are the three mechanisms. The carbon trading, when they trade with the other entities, and we have the joint implementation and the CDM. The difference between the second and the third is the geographical location of the green projects, whether they are in the developing countries, so it is under the JI, or in the developed countries, it is under the CDM. We have some basic assumptions for our system, because it's a core. We have to build the core system and then add to it more conditions, or when we have more issues and problems, and expand it. For our core system, which we tested and evaluated, and it was working perfectly, we assume that it has one administrator, in this case the United Nations. The smart contract is initiated once, and it's where the seller is, when the seller is intending to sell its surplus assigned Kyoto units. Kyoto units refers to the carbon allowances. or when there is an emission reduction project that is certified and ready to sell its shares, the administrator is the one who deploys the smart contracts and specifies the input parameters. We will be shown lately. And also the smart contract supports one seller, one emission project, and multiple buyers, which could be extended, of course. And the only buyers need to register in the system because buyers means they are emitters. So they are exceeding, they are causing harm to the environment. So when they register, they have to pay fees. However, sellers are not supposed to register or pay fees. And brokers are prohibited. The existing on the ground carbon emission trading mechanism is suffering a lot because of the brokers, because of the problems they are caused by them, not only in terms of cost, in terms of double sell of the allowances. And if you know if you have any information about the cryptocurrency, there is no double spending. Your Bitcoin is your Bitcoin. It cannot be sold twice. So in this case, our carbon emission allowances is my carbon emission allowances. Nobody can sell it twice. This is a very important thing. Brokers used to sell twice, increase cost, leak data, and that is private and related to the process of the organizations that are emitting. Now we have a new system which we are proposing. We have the smart contract, which we are adopting Ethereum blockchain that proved its effectiveness lately, especially after going through two forks, the London fork and the Berlin fork, and they were major ones, especially the lately fork, and the blockchain did brilliantly in terms of stability and security, and it continued working. So this is why we chose Ethereum, and we are using Solidity as the language. So the United Nations will be distributing the allowances to the entities through the blockchain, through the smart contract. The same thing will be with the green projects. The whole selling and buying and trading of carbons and offsetting of carbon will be going through the Ethereum, and dollar will not be used. We will be using Ether instead. Okay, so this is the message sequencing, how the logic is going on. First, we said that the administrator will be launching the smart contract. It will be deploying it by first specifying the unit price, means the allowance price, the Ethereum address of the buyer, of the project and the seller, and the quantity assigned for each entity. So we have to know first how much quantity of allowances is assigned to the buyer, how many is assigned to the seller, how many quantities the project can sell. Okay, because if, for example, if you are a seller and you are deciding to sell all your quantities, means you did not deserve them in the first place. So this is what brokers were doing in manipulating the market. So this is one of the ways to program everything in advance, write the logic in the smart contract. It is automated and it is transparent. Nobody can interfere and change. After the deployment, the buyer will register and pay the fees of registration. Remember, the buyer is the person, or sorry, the entity that is emitting more, that is causing harm to the environment. And then after they pay for the smart contract, the money will be collected to the administrator. They can initiate two types of functions. First function is buy emission unit function, where they can buy from other ones who are the sellers, and they settle the payment, and the money, you can see the transfer of ethers. So first, the buying party will initiate function buy emission units, send the ethers to the smart contract. The smart contract has the logic. So what it will do, it will transfer the ethers to the seller, and it will increase the buyer's unit quantity, which was assigned at the beginning here, buyer unit quantity. It will be increased because they bought from the seller, so they paid the ethers, and they are getting their units increased, and they reduce the seller's quantity, so the trading is done, and the transfer of ethers is done. Okay, and this way we have a successful emission unit trading process done, where we are emitting an event. And this is very important, to declare each trading process. Now, in case we have a list of transactions, and this list of transactions will benefit from the transparency feature of blockchain to make it available and seen to all stakeholders. So every transaction is seen. This way, any corruption, any way of manipulation, it will be seen immediately by all stakeholders. In addition to that, there will be a tracking for all the transactions that happen. Now, if the buying party decided that they want to do it in a different way, they want to offset their units, means they want to support some green project in any country, whether developed or or developing. So they can just initiate the function buy offset units. Again, the settlement will be done through the smart contract, and the ethers will be transferred this time to the emission reduction project to support their work and increase the units of the buyers. And again, there will be another declaration, okay, of a successful trading, and the transaction will be added. So you can see this is the logic of the smart contract, how it is going to happen. It is all will be it was programmed and tested using Solidity. These are the functions that were used. This is part of my program because it's a long program, and I'm just using a selective functions that are very important to show. Now, of course, as we know that working on smart contract causes real ethers when you are deploying your smart contract on the Ethereum blockchain. That is why Ethereum community through Linux provided an IDE, which is a testing environment called Remix. Anybody who works with that should know about it. So you have an exact copy of your Ethereum blockchain where you can test and use false ethers to test your program. Our program was tested first, of course, as you see here. I have my initial parameter set. This is by the administrator. I have my function register buyer, where I can have certain terms of requirements, or let's say conditions. First of all, for example, that the creator cannot be trading on, there is a certain way, a certain number or certain value of ethers that should be put as registration fees before a buyer can perform their operations. We have our, this is the registration part, this is the buy emission part, and you cannot, of course, sell all your quantities, because this means that that entity was not deserving them in the first place. And now we have a way of updating the quantities for buyer and seller. This is the offsetting function, and the same thing, we are transferring the amount of unit price which was specified at the beginning, the unit price here, and it will be multiplied by the number of units, means the quantity, whether they want to buy 1 allowance, 2 allowances, or as much as they need. This is just a screenshot of how it was successfully deployed. Each step was tested, and we can see first here that this tick here says that the smart contract was deployed correctly, and it was saved in the blocks of the Ethereum blockchain. And this one here shows the last step where the transactions have been done. Allowances have been transferred, ethers have been transferred, 2 functions were tested, the offsetting function and the trading function, and we can see these are the addresses of the buyers and sellers, and we can see how the amount of ethers have been changed according to the number of allowances that was traded. Now, to test our system and evaluate it, we will test it in terms of transaction cost and in terms of security. So as per the transaction cost, we just tested how much the total cost for deploying the contract and for running each of the 3 functions, registration and trading. We can see such a big contract will only cost $115 to deploy. Running registration will cost $7.9, and trading will cost between $11.6 and $12.25. This is nothing near to the cost that brokers take. It reaches to $500, $600, and thousands of dollars just to run 1 transaction. So this is in terms of cost. Now, in terms of security, you can see that we have labeled our functions in a way that they make it distinctly defined for the accessibility of the blockchain. We have avoided cross-section and calling from external sources. The smart contract addresses, when they are created by the Ethereum network, so it gives each entity an Ethereum address that cannot be forged or changed, because there has been problems with installation IDs created by the United Nations to companies. It was forged and changed. And we can see that we are providing features that enable tracking all traded allowances with trust, and that supports accountability for actions. And this is very important. In conclusion, we know that climate change is a risky phenomena, and the world took an action through the United Nations and created a protocol that is effective in its idea, but it wasn't implemented the perfect way possible. That is why the technology has to interfere and make the tool more effective. And what better than blockchain as a tool to provide security, transparency, accountability, and traceability of the traded allowances? We proposed our system and we built the logic. We implemented it, we programmed it, and we ran it, and we got the perfect results where there were no errors. And this proves that the result shows that it was capable of performing the trading of units, update the balances of all participants, and securely save transaction records and emit events. So our system is traced using ethers, transfer between parties to trade units, update their corresponding ether balances. These are my references. Thank you for listening, and I would like to hear your questions, please.
Thank you. I think we have time for a couple of questions.
Yeah, that would be great. Yes, please. Oh, so I have to sit or just decide?
Hi, thank you very much for the presentation. It was very, very interesting, and also it proves one of the main uses of blockchain, like the trading. I have a question, because you foresee an admin party. Like, do you see how this can work in practice? Who would be the admin party? Like, you have, maybe is a lack of knowledge from my side, but you need to have, like, from a decentralized system, you are foreseeing a party that is an admin. How do you see this working in practice?
Yeah, well, in blockchain, what happens is that, okay, I have to go back, sorry. I think your question is related to this slide, right? Okay. This is the problem when you are transferred from the cloud or the central system to the decentralized. It's a transfer of the way of thinking. So what happens in these cases usually, there are companies or blockchain developers, like such as me, I am a certified blockchain developer. We get the projects, just like you get the projects from authorities, and we write the logic. Now what happens is the authorities, which is the administrator, which is the United Nations in this case, and they have what's called the Climate Change Convention. They get the logic from us and they deploy it. They become a node, a full node in Ethereum blockchain, and they deploy it. And this is where they are specifying these parameters during deployment. Okay, they specify the parameters, and when it's deployed, it's there in blockchain forever. Now, the administrator can witness everything. Okay, and the control is not done by the administrator anymore. It's done by the logic of the smart contract. And when we develop the smart contract, we specify what steps that an administrator can interfere, because as we said, it's an automated solution. Okay, so we give them a certain power based on our negotiation with them, what we allow them to interfere with, and what is the rest will be done by the smart contract. So they can see whatever is going, everything is transparent, and the Ethereum address of the smart contract itself will be distributed to all stakeholders, trading emitters. So the emitters will join the blockchain as well as nodes, and they have the address of the smart contract, and they will open an account, buy ethers, okay, from the market, and then they will start trading using ethers and using the functions in an automated platform. Blockchain is a bit complicated. Like for me, I use the logic directly. Like I download Gith, which is the client of blockchain, and I start working. But usually for stakeholders, we provide what is called a front end. So what they see is a website or an application, and they start interacting. But behind the scene, there is no central authority, there is no cloud, there's blockchain running the show. So this is how it is going to happen. Once it's deployed, the administration will only have the authorities that was given to them by the smart contract. The rest, as per the logic, will be automated and done through the blockchain. I hope I answered you. Thank you.
We don't have time, but let me just put a question related to that
Sure.
question. Is the administrator that is responsible to regulate if an entity that is trying to sell credits in fact has that surplus?
Yeah, well, as I said in the beginning, you see by unit quantity here, by unit quantity. It is specified by the administrator. In the here, oh, sorry, I forgot, sorry, again. When the administrator launches the smart contract at the beginning, before the smart contract is put in the block and the block is put in the chain, these are the parameters set. One of them is buyer unit quantity. I have a lot of conditions here. I could not put them because it's a very long contract. One of the conditions that the buyer cannot buy more unless they already been assigned quantity and unless they already have registered and paid. Okay, and there's also a Boolean expression that enables the administrator to interfere, stop the trading if any alarm has been raised. Okay, so this is one of the, as I said in the negotiation, what to give the power to the administrator. Thank you. Any more questions? Thank you.
Shall I start? So, good morning, everyone. This is Ajay Moore from India. I work for Ministry of Rural Development, and currently I'm pursuing my master's in digital governance. So, this is the paper I'm presenting on behalf of all of my authors. So, the title says sharing a trust-based benefit delivery system in rural India powered by blockchain. So, the paper indicates or describes what is the importance and how we can efficiently deliver the welfare system and why blockchain is the best solution as an underlying technology to deliver this. So this is the content from the motivation. We'll go one by one. So what is the motivation for this study? So as we all know, like the deadline for SDGs is 2030, and every country, including India, where we have done this work, is determined to achieve this. And the major problem with all the developing countries, especially the larger ones, such as India, is we have very limited resources. And when we have to target the ultra-poor people, it is very difficult to target because there's larger audience there. And you have to focus whom to target for which dimension of the poverty reduction. And so it requires outreach, identification, and enrollment. And there has to be a process how we go holistically about it. The problem with this is we do not have any reliable socio-economic database. So currently in our country, we have citizen database and we have locational databases, but we do not have a socio-economic database which is dynamic. So for any poverty alleviation, the very first stage is to identify who is poor in which dimension, and how you address the poverty comes the second. So, and similarly, the purpose is to reach the beneficiary at the right point of time. So suppose for an example, we have to give a scholarship to a person who is in need for a scholarship, is poor enough, but he cannot wait for 2 years because he needs the scholarship now. So the timing is also important. At the same time, the transparency and security and privacy is important because whenever you collect the data with respect to a family or attributes which are personal or sensitive, the privacy aspect also comes in. And same, like when we have the centralized databases, there is an issue with respect to security and the vulnerability of the database. And we need, because like in other countries also, like in India, we have many verticals for the poverty reduction dimension. So we have different ministries who are dealing with, or the nodal agencies who are dealing with reducing a particular dimension of the poverty. So there is the harmony is required between them. And lastly, now we have a good penetration of internet and smartphones. So now it is time when ICT can be leveraged to deliver the benefit delivery system. So just to put things in perspective, this study, what it does is, currently in India, we have this citizen digital ID, which is we call Aadhaar, which is already present to identify a person And we have this locational identity, which is called local governance directory, so that we can identify a person where he lives. So because it's a big country, so you have to identify the habitations where the person is living so that you can target. But the major problem is poverty is a household phenomena. It's not an individual identity phenomena. So you have to have a unique digital identity for a family, and then you have to capture the socioeconomic attributes which are dynamic enough so that you can target the people who need it. So suppose a person who is skilled enough in a family, you need to give them employment. For a person who is pursuing education but is poor, you need to give scholarship. And similarly for pension and other attributes. So you need to target them. So just to see the magnanimity or the scalability which is required, you can see the programs which are currently run, they have such a huge existing databases which are running in silos with this much strength. So this is just lastly, with respect to motivation, why we feel this is a good business case for the government is how much savings, apart from what will it deliver with respect to achievement of SDGs, in terms of finance, how this program can succeed. These are the perceived benefits I have just highlighted. I'll just take a minute to showcase. So when this digital ID, this citizen digital ID was driven in India, the total cost from the beginning till now is only 1.75 billion USD. But the benefits it has given is a World Bank study says India can save 10 million USD every year just because of the citizen digital ID is in place. And in the Indian Parliament, it was quoted by Finance Minister stating within less than 2 years, India was able to save more than 12 billion USD. So this is with respect to citizen digital ID. Now we are proposing an integrated social registry, which is the need of the hour. And just one scenario I have highlighted here, which indicates how much money could be saved. So this scenario is with respect to the sanitation program, where India wants all the villages to be open defecation free, so that every individual, the poor family, has a toilet with the household. So if you can see, when you have multiple databases, there is no single source of truth. The problems occurs. In 2011, we had our holistic survey, which says only 179 million families are there in rural India. But this sanitation program, without relying on a single source of truth, they went on for their own program for survey, and their survey identified only 169 million families. So there was a gap in outreach. Similarly, we see they identified that number of people with having toilet is 58 million, and without toilet have 94 million. But actually, the families should be 110 million based on the total survey what they have done. So there's a gap in targeting. And lastly, there is an issue with respect to multiple programs attending to the same dimension of poverty. So if you can see, toilets constructed under the sanitation program were 107 million, but at the same time, another program, which is rural employment program, also constructed toilets, 3.8 million toilets. So there's a duplication of work which was happening, and one unit cost was 160 USD for one toilet. So you can just imagine, with respect to only one dimension of poverty reduction, there's a lot of duplicacy, there's lack of target, you cannot outreach the poorest of the poor people. So this is why we feel that this is required, integrated social registry is required. Now comes the underlying technology, why blockchain is the best solution for this. So we started this study, and this is ongoing work. So we started pre-COVID era, we started with this. And at that point of time, this is taken from Gartner's study. So they say these are the technologies which are emerging technologies in digital governance arena. And if you see blockchain in government, this technology has now passed the hype, and slowly it will become the reality like cloud and other technology. And there are huge cases of blockchain. So apart from the financial sector, there are huge there are use cases for blockchain. But here in this scenario, some of them can be used are secure data entry. So I'll just highlight how it is happening currently, because the programs are survey driven. So we have highlighted in our paper, whenever the programs are survey driven, the beneficiary knows, or the people know it is for what. So the data quality is poor. That can be avoided. And the paperwork is already getting avoided by digitalization, but blockchain will enhance this. There would be integrated data management, so which we highlighted the silos. The ministries are working in silos. There is no collaboration. And it will combat the corruption. And again, it would be interportable. We have also suggested how interportability can work well in blockchain when we have the complete framework. So now this was the part of the motivation. Now in this paper, this is the scope. So in the literature when we reviewed, this is the common social welfare delivery chain. So these are the you can say the milestones in any particular social welfare delivery chain. But so blockchain, when we have a blockchain-based IT solution, it will help us in not only potential eligibility identification, but also to decide what benefit to give, and as well as in the implementation of the programs. But in this paper, we have highlighted only the first scenario, wherein the integrated social registry can help us in outreaching and can also help us in identifying who the people are, who the families are, to whom we have to give the benefit. And here, if the underlying infrastructure is blockchain, this would be more transparent, decentralized, and more interoperable. So in terms of literature review, we tried to do some of the seminal works and some of the works which are related to blockchain as well as the social registry. So we have gone through some of the studies in multilateral organizations, in government organization, as well as academia. So 2-3 things we have found out. So the below study, the more holistic study was done by the World Bank study, which says how the social welfare, for the social welfare delivery, how this integrated social registry can be developed. And there are certain studies which say how blockchain can be used for this social welfare programs. So after reading all this and reviewing the literature, we found there's a research gap. So most of the blockchain use cases which are there in the government, they are in the pilot phase. And because of the security and the privacy concerns and the scalability and the cost-benefit analysis, the governments are hesitant in adopting it in a full scale. But at the same time, they have not used, any of the government has not used this to create a social registry. And here we will be highlighting in this paper how the social registry can be built on blockchain. So one objective of the research would be how the components can be fit in on the blockchain. Another would be, the major one would be to identify the challenges which are coming in adoption of this technology in the social sector. So as our title, title of the paper suggested, the blockchain will bring more trust to this governance. So first we identified what are the trust deficits which are currently happening. So one is related to data security and privacy. So when we talk about citizen data, we have sensitive personal information. So like GDPR in India also, we have this data protection bill, which is soon going to become an act. So there's a problem with whenever you are collecting beneficiaries' data, how you are using it, be it government, be it private. So that concern is there with the centralized databases, because the control of the centralized databases is with the very limited people. So there are issues with respect to tampering of the data. There are issues with respect to their compromise. There's an issue of leakage. And also there is an issue with respect to the cybersecurity threats which is happening currently. Now the issues faced by the beneficiary and citizen, because the databases are not decentralized, the citizen is not part of this governance chain. So there is a lack of transparency. The people are not aware because the governance is not proactive. So people are not aware like for what benefit they are eligible for. And lastly, there are issues with respect to scalability and interoperability. So as I showed you, there are duplication efforts. So there's need for reduplication. Like everyone is working. India has a federal structure. So the state governments and the central government, everybody is working for the poverty reduction. There's a lot of duplicacy is happening. So in this way, we can bring more interoperability so that this duplicacy is enhanced. So now how the blockchain will bring this digital trust? How this, in the last slide, as I mentioned, what are the gaps and how this will bring. So firstly, it would be a shared platform. So decentralization will be there. So it will enhance, it will solve the problem of our security. Immutability will solve the problem of inconsistency as well as the integrity of the data. So there are issues when the data is collected from two sources, which one is true. So it will bring the single source of truth in a chronological order. The encryption will give more control over personal data. And now we have zero knowledge proof and other protocols which can be embedded into this so that there is no leakage of data. You can prove your eligibility by showcasing what your socioeconomic aspect is without revealing them actually. And now on the top of this blockchain, the smart contracts will actually help the poor people, especially farmers or in the health sector. We have seen the insurance companies as well as the governments. They are sometimes not delivering their promises. So when we use a smart contracts effectively, there will not be an issue with respect to the obedience to the law. And it will eliminate the biggest challenges of middlemen, those who play the role in identification and selection of the beneficiary. So this will be eliminated because from the blockchain, every department would be a node and they can easily see who is eligible for particular benefit, and that would be delivered without any role of intermediaries. And it will also help, the major one I want to highlight is this ring signature concept. So because of the implementation of ring signatures, what will happen is the vision of the government, especially the developing countries, they face the challenges with respect to the face of the government. So they want a faceless and cashless government. So cashless problem is solved by direct benefit transfer when you transfer the money directly to the beneficiary. But faceless concept comes when you implement ring signatures, where the accountability is not on one person, but it is the number of people who are there in a chain. Anybody can sign it, and the ownership would be of the organization, not to a particular person. And so what kind of blockchain technology we are going to adopt this? This we have highlighted in our paper, that private permission blockchain would be more suited here and not the permissionless blockchain, because there are issues with respect to energy consumption, what they consume in the permissionless blockchains. And the participants will be known and pre-approved and vetted, so there will not be any requirement of POW or POS, and more realistic consensus algorithms can be used, which will reduce the energy consumption and which will reduce this latency. And because we also need an optimal balance between cost and benefit, because most of the things in silos can be achieved by decentralized databases and distributed databases. So if we are adopting any kind of technology in government, there should be a clear-cut balance between the commercial aspect associated with it. Now, so the concerns department can mutually agree upon fault tolerance rather than using any POW kind of consensus algorithm. Fault tolerance can be used, and one leader can be defined and others can follow it. And similarly, the departments, so there are a lot of departments with the federal government as well as the state government. They can become the node of the chain, and then they can onboard the people, or existing data, whichever they have, initially we'll be onboarding this. So this is an ongoing work. I'll just show how far we have reached. And lastly, with respect to the citizen or the people on the ground who are actually using it, so blockchain explorers with a very user-friendly GUI or the QR codes can be used for verification of this and effect. So whether it is the person is there on the chain or not, it can be easily verified. And similarly, we need not to store all the details on the chain, so only transactions with the unique ID can be stored, and the associated data such as photographs and others, they can be offloaded and can be captured separately. And as mentioned, zero knowledge proof can be used so that people's privacy is protected. They can prove themselves that they are eligible for particular scholarship or particular benefit, but they need not to reveal their information. And scalability, so cloud technology can help in the scalability aspect. And because the blockchain is so open, so it will help us in convincing the other arm of the government, which is comprising of auditors and all, those who find it difficult because the data is not shared generally in developing countries. So data is not shared among the departments. And this transparency is not only between the citizen and the government, it is within the government also. The departments do not share. So this will help in decentralization. Some of the challenges while discussing in the literature as well as discussing with the people, we have highlighted some of the challenges in the paper, and some of the suggested measures we have also given. So what can be done? So they are one-to-one mapped. So few of them I'll just highlight, like multiple departments need to work, so the nodal department can issue the mandate. There is an issue with, especially in India and developing countries, there are issues with respect to digital literacy and digital divide. So assisted services can be provided, like there is a common service centers there in the villages, and the people who are a bit literate can help others. And similarly, sharing of the data, so that mutual protocol has to be agreed upon. There is the perception between the government people that this technology is very complex, so you need to give them the very user-friendly interfaces with their own regional languages, so that the complexity should be abstracted. And so similarly, if there is an issue with respect to loss of keys, so you can engage the third parties for the key vault management. And there would be huge issue with respect to loss of jobs. People perceive the technology will take their jobs away. So there's a requirement for upskilling the people, because now that more technology-oriented work will be there. And lastly, there's a requirement for a framework. So government should come up with the technical as well as the legal framework when they want to adopt this. Lastly, so as I told you, this is just an ongoing work. We are currently on to it because of the COVID pandemic. We were unable to finish our work. So this is an ongoing research. What we are doing currently is we are doing a POC in a district in India where I have highlighted 5-6 programs with respect to employment, housing, and pension and skills. So those the data with respect to those programs we are collecting. And based on the learning of this POC, the issues would be presented on the similar platform. We'll be given opportunity as well as to the government of India so that they can see the benefits and then they can adopt it. So this is our current proposed approach. What we are doing is we are studying all the scheme guidelines which are social welfare schemes running in India. We are studying their MIS systems, and now secondly, we are at their stage. We are merging all the databases by deduplicating every record with the means which are currently present. And once we identify the golden records we are deduplicated, we'll be porting them onto the chain so that there is a unique ID given to every family. And then the dynamic nature of social registry comes into place, wherein whenever any benefit by any government is given to a family, it is onboarded chronologically on the chain so that other parties can review it, and based on that, government can work proactively. So suppose my family is poor enough and I have crossed an exam and now I'm eligible for a scholarship. Rather than it should be a demand driven, it should be a supply driven, and government should approach me saying you are eligible for this scholarship. So this will help us, this dynamic nature of social registry will help us in delivering proactive governance. So lastly, because the study is not completed, so we have not highlighted all the conclusions, but major conclusions are this kind of permissioned blockchain uses will increase the trust in the data, because within the government as well as for the third parties like media, NGOs as well as the citizens, and it will enhance the reuse of the data. So currently every department is collecting the data and they are relying on their own data. So this will help this. Otherwise, if there is no integrated social registry, currently what is happening is every department is creating their own centralized databases. So later on, the same challenge of interoperability will come. Lastly, the confidentiality and privacy will be inbuilt in this system. So that is a major concern currently in my country as well as across the globe. So this privacy can only be attended based on the laws in place that has to be in compliance. The blockchain will be a great tool to do that. And lastly, it will enable for more targeted outreach. So the problem is government is giving social welfare, but it is not reaching the correct people. So once you highlight that these are the people who are eligible for particular benefit, you give the treatment. And lastly, this will help us in examining the pre-experiment and the post-experiment results. So this is the last aspect. And the social sector has been capacity constrained. So once this is implemented, this constraint would be hugely removed because of the scalability and interoperability. Thank you.
Thank you, Raj. Ajay. Okay, thank you. Very interesting topic, but I have a few questions. You said you are going to use private blockchain. Are you going to build a blockchain by itself? Like, is it a big project that is supported by the government, where you can choose your consensus algorithm, and etc., or you are going to use one of the existing blockchains? This is one question. And the second question about the privacy. Now, I don't know about the privacy rules in India, if they are strict like the ones in the United Nations or European Union areas and all these things, but how you are going to incorporate them in your logic, and what if they are changing? Okay, because changes happen in the laws, and your smart contract is immutable, right? And the third thing is about your proof of concept. How you are doing it on the ground, how you are testing your proof of concept to know that your concept, practically, you've shown me the steps of how you build your proof of concept, but how you're testing it and making sure that every step is the right one. I know it's too many questions, but it's an interesting topic.
So I need your help. What was the first question? Just here, you can just say, because.
About your blockchain, are you going to build a blockchain?
Yeah, so Yes.
Because the difference between building a blockchain and developing
Correct, correct. So this is just a POC we have proposed to the government. So the POC currently we'll be doing on the platform, say Ethereum-based platform or Hyperledger. But later on we will be proposing, because the scalability of this program is huge. So as I told you, in India, only just in rural India, there are 240 million people living, 240 million households living. So we are talking about household and they will have members. So it's a huge program. And as you told, e-governance is to support the governance and not to dictate the governance. So there would be a problem if we use something which cannot be changed later. So we will be proposing that government builds their own infrastructure. In India, some of the state governments have also highlighted this. If we have the blockchain infrastructure by the government has the capacity to fund such kind of things, and later on, these smart contracts or the siloed chain can use that infrastructure. What was the second one?
So you are not decided whether you are going to
No, so we'll be,
existing blockchain or you are going to build a one, but based on the population you are having, you think you have to establish.
yes,
Otherwise
yes.
you will crash the.
Yes, firstly will crash, secondly it would not be customizable. So as you told, like the policies change, the rule change, and based on that we'll have to tweak with the things.
Plan for the change of policy, how you incorporate that in your
No, so I'll answer it. It was the third one. I think second one you asked for the,
concept. How
I think privacy one.
yeah, the privacy once it's changed.
So, yeah, correct. So in India, currently, so based on GDPR and other experiences, India has come up with the data protection bill, which is passed in one of our parliaments. So we have two parliaments, upper house and the lower house. It has passed in lower house, and it would be passed in the upper house. And it is as rigid as GDPR. So privacy is one thing which is we are focusing hugely. And this data, because it is socio-economic data, so it takes everything from your personal attributes as well as your economic attribute that can be exploited not only by the commercial entities, but also in sense of cyber terrorism and other aspects. So it is very rigid. And as you told, like how we'll be accommodating this. So we'll have to decide for the tenure. Currently, when we are doing this, we are focusing that government has to be liable, that they cannot change the law without informing people and without taking them into the loop. So suppose a smart contract, it would be delivered for a certain period of time, and it would be renewed again and again. So if there is any change, with the consensus of the beneficiary, it would be changed. Okay.
And your proof of concept, how you test that?
For the proof of concept, so what we were figuring it out currently, if we'll be going how the cryptocurrencies are going, it is very consuming with respect to the energy and other aspects. So what we are thinking of, the government should come up with their own consensus algorithm, what kind of tolerance they can allow. And generally, so we have this BFT algorithm for this fault tolerant. So there is one kind of algorithm where you define a leader and then others follow the leadership. If they want to change the leader, there is the protocol they can change. So generally in the benefits, because they are delivered top to down, so we can define a democratically elected body as a leader and others can follow that. And lastly, because once this is completed, we'll try to showcase the complete results on the similar platform if given opportunity. Thank you. Thank you.
Now we have one more presentation, this time a very important one, with our special.
algorithms, and technology used by these projects for the development. As we know that Santoshi Nakamoto introduced blockchain in 2008. Many authors expressed blockchain in different ways. Generally, blockchain is a growing list of records that are linked using cryptography. Tiravia Swayambhu expressed that blockchain technology is not a brand new innovation. It derives from decentralized peer-to-peer networking, consensus mechanism, and cryptography concept. Already we are using these concepts in networking and data security applications. Applications of blockchain. Bitcoin is the first application of blockchain, which is cryptocurrency. Further, blockchain stepped into various fields like financial, government, healthcare, education, supply chain, and so on. Versions of blockchain. First version of blockchain is cryptocurrency. Second version of blockchain, smart contracts. Smart contract is a computer code which executes when doesn't require third-party agreement. Third version of blockchain, DApps. One can implement decentralized applications based on their requirement using blockchain platform. Fourth version of blockchain is the BaaS. Blockchain as a service. Amazon using this service. Type of blockchain, public blockchain, that is permissionless blockchain. Private blockchain, that is permissioned blockchain. Hybrid blockchain. One can use hybrid blockchain when they need both public and private blockchain platform. Government, institution, and IT sectors like IBM, CTS, Oracle are using blockchain technology for secure and transparent data communication. Most of the countries are adopting blockchain technology in their government projects. Some of the blockchain projects, Honduras and Georgia started land register applications. China announced blockchain city. Singapore uses cross-border interbank payment system. Ukraine uses election platform. Estonia adopted blockchain in e-health. US secures patient health record. India announced India Chain, which is Niti Aayog large-scale blockchain-based project. Why we need to use blockchain in education system? Career Builder found that 33% of applicants register with fake documents. The Rector University and Philippines Diploma Mill offers fake degrees. Judge Jenny filed case against court clerk who submitted fake school record. MIT director identified that Miss Merle Jones, the former dean of admission, submitted her fake degrees when she was appointed. So one can use blockchain technology in an education system to avoid fraudulent degrees, reduce manual administration work, and support institution employers to verify the documents automatically. Here we focused on the various authors' work. The authors analyzed and discussed the applications, use cases, issues, and challenges of blockchain in education system. Here we discussed on student digital certification. The authors designed proposed blockchain-based system using Ethereum and Hyperledger. Some authors use JSON, CostDB, BFT, and chaotic algorithm to develop application. Here we focused on blockchain-based educational tools. EDU-CTX, it allows higher education institution to join the network, integrates the students and organization, uses ECTX tokens. Blockchain, implemented to overcome the block set issues. VJTI blockchain, designed for VJTI Mumbai, India, uses Python 3, JSON, REST services, and proof of authority algorithm. SmartSet, implemented for Al Jaituna University of Jordan, maintain all official documents using blockchain. TCER Square, it adopted by Salvador University, developed for academic and industry professionals to manage educational assets. These 18 significant works are analyzed with services and technologies. Most of the works focused on issuance and verification of digital certificates. Some of the works stores certificate using smart contracts and OCR code. Some of the works exploring use cases and applications of education systems. Some of the work uses mobile application and security teams. When we're going to implement something, we need some prior knowledge about that. So here we have classified the 30 educational projects into 5 categories. These are the projects classified based on above 5 categories. First category is universities and the institution are using blockchain. Second one, learner performance analysis. Third one, educational marketplaces using blockchain. Fourth one, issuance and assets of digital certification. The fifth category of this, provide a platform, block-based payment and reward system. First category, blockchain in universities and institutions. Blocksets. MIT uses blocksets, open platform for issuing digital certificate, shares credential to employers. University of Nicosia, first university to accept tuition fees, started courses in Introduction to Digital Currencies, MSc in Digital Currency. Shares certificate with unique code. Open University UK issues certificates and badges, collaborated with University of Jen and University of Texas. Maltese Education Institution allows Maltese people to store their credentials. University of Birmingham implemented BTset to resolve the blockset issues. Uses Java, JavaScript, JSON, and MongoDB. Authenticates certificates based on QR code. Second category, learner performance analysis using blockchain. Open source university authenticates the students' academic credentials, allows other educational institutions and employers to verify student credentials. Cubomania, it uses AI, IoT, robotics, creates and transmits the education content. Cubobuddies is the tool to analyze the learning style of learners. Picapa provides efficiency to the education field in the sub-Saharan Africa. Third category, educational marketplaces using blockchain. With University, blockchain-enabled university, allows academic institutions to launch and teach the courses. ODEM, it connects service providers, educators, and students. Uses Ethereum and smart contracts. EduChain is a platform of Dubai and launched the world's largest model of blockchain technology. EchoLink stores the verified data of an individual's personal career on the permissionless blockchain. It supports both on-chain and off-chain blockchain platform. EduCTX, designed for University of Maribor and uses ORG platform, allows students, employers, and institutions to verify their certificates. Issues their certificates to the participants, those who are attending lectures, workshop, and training. Lightchain is the first double-layer consortium blockchain, organizes the online quiz and evaluates the answers transparently. English Forward is a platform to people, those who want to learn English language, adopted blockchain technology in 2018. Uses Banker protocol to improve their service. Success Lab organizes the seminars and workshops. Vision of Success Lab is to be the world's leading provider of life-changing education. Category 4, Issuance and Assets of Digital Certification. Halberton School of Software Engineering, first institution to issue hard copy and digital certificate. Verification done and project activity. Sony Global Education is a new educational platform partnership with IBM to secure and share the students' records. Started the Global Mathematical Challenge in 2018. API verifies the academic background and the qualifications of both students and teachers using smart contracts. GradPace uses Bitcoin technology to verify the educational records and QR code LinkedIn web browser extension. Stampery uses Bitcoin and Ethereum platforms to verify data. Uses proof of method based on routing keys and creates the scalable, cost-effective bindings. Origin stamp ensures the security of digital data by using fingerprint of clients. Turing chain redefines the traditional educational certificates into digital certificates, uses AI, blockchain, and natural language communication. Edgecoin, it uses smart contract to store credentials of the candidates, skills, and employment history. Disciplina, platform for academic institutions and companies to store candidate details. We can filter potential candidates based on scoring system. Records keeper, issues digital certificates and receipt to the user, allows others to verify based on receipt number. Open certificate receives the degree, diploma certificates, uses IPFS and smart contracts. Category 5, payment and rewards offering platform. Qtless is a company that has agreement with 80 universities, provides a platform to video courses and rewards learners and educators based on their performance. EduPoint, online educational platform, evolve with the teaching quality using smart contact. Gigamaze, knowledge sharing social network platform, connect readers, authors, and service providers of book industry. Uses Ethereum, IPFS, and smart contracts. Here we differentiated 30 projects based on their services. Most of the projects are supporting digital certification. Some of the projects offer course and learning platform. Some of the projects offering payment of fee. Very few projects are supporting skill sharing platform. So effective usage of this project, 55% of projects support digital certification, 23% of projects offer payment of fees, 16% of projects offer course and learning platform, and 6% of projects provide platform to share skill. Here we have compared 30 projects by what is the intention of project, which blockchain platform used, what is the consensus algorithm used to prove the work, and unique technologies used along with blockchain for implementation. Open University, Sikapa, and Wolf University using mobile application, Cubomania and Odom using AI technique. Here, Success Life and API using machine learning technique. In this, Turing chain Educoin using AI technique, and Open Certificate Gigamaze using IPFS platform. Conclusion of our work, we have surveyed on 52 research work to analyze applications, use cases of blockchain in the education system, focused on student digital certification and educational tools to realize how student certificates are stored, issued, and verified by the institutions and employers using blockchain. Classified the 30 educational blockchain projects into 5 categories based on their services. As I mentioned in previous slides, 30 projects are differentiated in detail. From our survey, the majority of the work focused on student digital certification. Apart from maintaining student digital certification and fee payment, one can use blockchain technology to implement admission process, scholarship refund system, feedback analysis, and research activity progress report generation. Here, these are the references we quoted. Thank you all. I would like to thank conference organizers provided me opportunity to participate in this conference through virtual mode due to COVID-19 situation. And I would like to thank my research guide, Dr. Muralidhara BL. He initiated and motivated me to participate in this conference. Any queries? Mail to sarala5111@gmail.com.
Okay, so I think we can end the session. Thank you again for attending. See you around.
Thank you. Thank you. Okay, hello everybody. Thank you so much for coming to the track titled Digital Governance and Geographic Inequalities. The theme of the track are the key differences between the adoption and the priorities of e-government and digital governance between different countries and regions, among other key factors. We have four very interesting presentations today. One is going to be physical. We have Morten Meyerhoff Nielsen with us to present his research on digital inclusion and gender-associated indicators. It's a literature critical review of all literature posted after 2010. And we have three more pre-recorded presentations that we're going to share afterwards. What I propose is to have Morten have his presentation right now. We will have some time for questions after his presentation, and then we will play the pre-recording presentations. So I hope that you will enjoy the session. Also, let me just present myself because I didn't do it beforehand. My name is Panos Kourthanasis. I'm a professor at the Department of Informatics in Union University. My expertise is on e-government and information systems. So I was also the track chair of this track, and with Maria Alexandra Cunha. So I'm very happy to be here and hosting this chair. So let me give the floor to Morten, and let's all enjoy the session.
Well, thank you. And because there's a big room with lots of social distancing possible, I'm going to take the mask off for the presentation. Hope you don't mind. I am fully feisted up. So anyway, I'm here to present joint research on the digital inclusion and particularly what we call the digital gender divide. And we've done this as part of ongoing research at UNU-EGOV. Mercy, my co-author, is actually the lead author on this. She hails from Nigeria, educated in Hungary and Portugal as well, so quite interesting background. I myself is obviously male and Danish, educated in South Africa, Denmark, and the UK and Estonia. Anyway, to give you a little bit of an introduction, we're going to look at the context of digital inclusion. Then I'm going to take you through our methodology and what that literature actually tells us in terms of what we found and make some concluding recommendations. So first of all, a bit of the context. Digital transformation is associated with both negative and positive elements. Digital divides is one of those potential negatives. Digital inclusion is a positive. Yeah? So we're looking at inclusion or exclusion as two sides of the same coin. Digital inclusion is a key focus of the UN Sustainable Development Goal, and gender equity and gender equality is a particular focus around SDG 5, which is looking at achieving gender equality and empower all women and girls. And here we're looking at not just digital inclusion, but also financial equity and so forth. Now, digital inclusion is not just about bridging the divide between those who have access to technologies and those who do not. It's also about how the technology is being used and how you access the opportunities around the technology and the digital transformation. But what we've actually seen is a number of global trends in terms of equity, in terms of gender in general, since the 1970s have been positive. But what we've seen since the financial crisis in 2008 is actually that a lot of these gains are being eroded, particularly around gender and gender equity. So what we're actually seeing that while 200 million fewer women and girls globally had access to the internet in 2016, this has actually risen to almost 330 million by 2018, which is the latest data on this specific element. So we're seeing that although there's population growth, we're seeing the divide between men and boys having access to the internet is growing faster than the equivalent growth rate amongst women and girls. So we're seeing that the gender divide is actually increasing. Yeah? This is particularly relevant when we're also looking at job opportunities and with the digital transformation of the economy. So we're seeing that women and girls are potentially left behind in greater numbers. Now, in terms of the methodology and our research questions, we were actually looking at what are some of the underlying trends highlighted or some of the underlying issues around digital divides, digital inclusion, and gender in particular, and what are the type of indicators that researchers are basing their research on. Yeah? So we did an initial scoping review. And between 1951 and the end of 2000, we actually found that there was more than 8,500 peer-reviewed conference articles, journal articles, special book chapters, etc., published in English on this topic, but mainly on gender and gender equity. When we narrowed it down to gender inclusion, and we saw that around 208 journal articles could be identified between the 1st of January 2010 and end of December 2020. Now, why did we look at that specific time frame? A, was to limit the analysis that we needed to do, but also the critical mass of internet rollout and access to the technology in theory have reached a critical mass by 2010. So we saw with the advent of the internet in the early and mid-90s, this was mainly focused on developed economies, but there was a lag with the popular take-up and the rollout in emerging economies. But what we also expected and what we found was that pre-2010 findings were often captured in the post-2010 literature because obviously academics do research based on other people's work and adding new elements to it. But when we looked at the 208 publications on gender and gender inclusion, we could exclude about 116 of them, so over half, because they focus specifically on technology in healthcare provision and not necessarily on digital inclusion. So it was technology in providing primary care, assisted living, particularly to women, but also to seniors, so it was less clear. So our core scoping resulted in about 92 publications, or 44% of the initial, and it focused specifically on digital, inclusion, men, women, boys, and girls as keywords within the texts. We specifically did not look for data or indicators because we both wanted to see where the focus on research had been, but also to capture some of the data elements and the data collected in that regard. So when we started going through the different literature, we noticed that there were some patterns. So first of all, the gender gap or digital gender divide or gender-based digital inclusion or inclusion was a key focus in about half of all the publications, but often in very generic terms. Financial inclusion, so access to financial services, both digital and otherwise, was a topic in about 22%. So digital inclusion, financial inclusion was seen as going hand in hand by many researchers. Despite having excluded more than half of the original sample because of the focus on healthcare in terms of technology use, we did see that in the remaining sample, about 10% of the publications did look at IT or technology-enabled healthcare or assisted living in relation to gender. Yeah? So very specific. So the keywords of men's, boys, women, girls came up in this literature. Then there was a category around digital communication, cultural context, and diversity, and I'll go through those in greater detail, but we see some dominant themes. One of the observations we quickly made was that digital inclusion tend to be a catch-all phrase across literature. A lot of reference is made to digital inclusion, digital divide, digital inclusion, without going into detail or being very specific in terms of what type of parameters or what type of drivers or barriers are at play. So it's a catch-all phrase, and it also often refers to both digital, financial, social, economic, political inclusion. So again, we see it as a catch-all phrase, a bit like technology is. So this was very surprising that there was very little specific discussion of what we meant by digital inclusion or digital divide. What we also saw that reference was generally made to the concept in relation to equity or equality. Yeah? So again, equality and equity in access to education, healthcare, jobs, public or private services, or even decision-making processes. So when we looked at it, we could actually look at digital inclusion in terms of a very strict definition, which is the ability to access and use digital technology in creating economic or personal value from that access. And that's proposed by Jaeger already in 2012. So again, he came up with these definitions based on having looked at pre-2010 literature. So another important aspect was the digital gender divide, and this stems really from a collection of social and academic perspectives related to the digital transformation and inclusion. Now, some scholars were seeing this as actually problematic from an ideological perspective. So the literature actually reflects that digital inclusion and gender is actually problematic as a research discipline in itself, because by looking at a specific gender, you are actually excluding other genders. So this was quite interesting. And also, there was often discussions around the lack of a distinctive philosophy and related to socioeconomic settings, partly based to also the earlier literature on the isms, so liberalism, socialism, communism, capitalism. So again, it was seen a little bit in relation to the context within marginalized communities in general. Now, what we also found was that data on the term tended to focus on very much first-generation digital technology. So focus on internet access and traditional educational skills. So they were looking at skills related to reading, writing, math, but not on digital literacy or digital skills, or even problem-based creativity, critical thinking skills, which has come up more in research related to the second digital divide, which is focused more on the affordability of access and the creative consumption of digital content, and also producing digital content rather than just consuming content from the internet or tools. And again, we also saw that most literature use data from the same sources, which explains this. So the ITU databases for telecom rollout availability, so the International Telecommunications Union, is dominant in particularly emerging economy-focused literature. In Europe, we see that Eurostat's ICT household survey was often used because it's more granulated. We saw in North America the Pew Institute and their collection of data was prevalent. But also organizations like UNESCO and their skills and capacity database on educational attainment levels was a key source of data. So was the World Bank and so forth. So again, some of the explanation on the specific focus of the literature can perhaps also be explained by the data available for international studies are only focused on national countries, so national averages, not regional or local breakdowns, and it is collected by key international organizations. Now, we didn't look at the quality and the granularity of this data in this specific study, but we did do that in a previous study where we assessed the monitoring and measurements initiatives around digital inclusion. And looking at 9 global or regional examples, we actually found that although they had combined more than 300 indicators, only 9 of them focused on specific user groups, of which 7 was on gender. So only in 3 of these 9 global initiatives was gender a parameter they actually collected data on when it came to the use of technology or access to technology or skills. So there's an explanation there, perhaps. Now, also what we saw was some of these findings. So we tried to collect some of the most current statistics. We saw that, for instance, that the gap between genders are widening. We saw that women globally are 26% less likely to use the internet than men. We saw that this actually increases in regions like Sub-Saharan Africa and South Asia, where these figures are even higher. Now, the quality of access was also seen as an indicator and interconnected element with financial inclusion. And again, here there was an emphasis in about 22% of the sample literature on the focus on financial inclusion in order to enable the women and girls to take advantage of digital opportunities. Obviously, you can't shop online if you don't have a card, mobile pay, or SMS-based means of transferring funds, so there's a logical connection there. Again, we saw the assisted living and IT-enabled assisted living coming up. Quality of access was one cluster, and also the affordability of access. Actually, some other research that we've done at UNU-EGOV indicates that currently it's not the access to infrastructure or devices that's the main barrier for people. It is the affordability, the relative cost of the internet access. So we see that particularly in emerging economies, although they have 2 or 3 mobile providers, there's still gaps in the quality or parts of the country where access is not reliable, or we see that it is just so costly that it's not reachable for large proportions of the population. So again, we saw this, and that limits the ability. Now, in terms of skills, we saw that this does not only relate to digital skills. We saw that the digital gender divide, so that critical thinking and critical constructive ways of using digital opportunities was a key challenge, and that not all women are yet to capture that. Now, this was highlighted by the research, yeah? So we're not making any judgments, we're just reporting back on what we found in the existing research. We also saw that while specialized ICT skills are becoming more significant, the findings indicated that there was a particular gap with gender. So for instance, we saw that some research in Sub-Saharan Africa indicated that while 5% of boys in primary or high school sees themselves as working with IT or tech, within the IT and tech sector in the future, this was less percent amongst girls of the same age groups. Yeah? So we see again that boys tend to be more focused on that. It may be related to some researchers find the masculine undertones of technology. So there's a legacy of technology being developed by men for men, yeah? And that might be part of that. But we're also seeing that even if we look at STEM graduates, so science, technology, engineering, mathematical graduates at university level, we see again there's a gender divide even in the data. So there's a big gap in the number of graduates coming out to future demand, but it is mainly men and boys that are pursuing those type of degrees. We did see some interesting variations in some of the European data and literature, where interestingly some countries like Bulgaria have far more women searching for opportunities for education and jobs in engineering, computer sciences, compared to, say, other Eastern European countries or even Northern European countries. So we saw some geographical variations, partly explained by a traditional cultural focus, historic focus on engineering or computer science coming through. In terms of the indicators, we saw a lot of stuff. We already know that approximately half of the world's population is online or have the theoretical ability to go online. But we also saw that there was some cultural issues around that. But we'll get back to that later. But we saw that there's still this big gap. Some research has indicated, so empirical research have indicated that once half of global population is online, the rest will follow. We see that also at national levels. But again, the divide is not caused by the theoretical access to the technology, but rather the affordability or the perceived value of that. So again, men are more likely to use it. There's an increasing divide between also developed and less developed economies in this regard. So particularly low-income countries are battling with keeping up with international trends. We actually have seen in the data in other studies that the divides and the trends seen pre-pandemic has been accelerated and is being cemented by the pandemic. So some people argue that we've done 10 years of development in terms of tech and tech take-up in the last 2 years because we've been forced to use technology because of the lockdowns. So again, it's accelerating existing trends, and unfortunately on the gender divide and on geographical divides, that's a negative trend and a widening gap. What we also saw very interestingly, and this came out particularly in the North American literature, is a focus on race. Yeah? Race or religious ethnicities, cultural backgrounds. We saw that particularly in the Pew Institute studies, and we saw it in pockets in countries like India or sub-Saharan African literature. But what was also very interesting was that the majority of this literature is on developed economies. It's not on emerging economies. That we found was very, very surprising. Yeah, because the digital divide is proportionally a bigger challenge in emerging economies, but that's also where there's less data available and less research available. So again, there seemed to be a negative negative spiral here. In terms of some of the recommendations is obviously looking at not only gender and marginalization and digital inclusion, but really to try and analyze it more and breaking it down also in terms of the data available. If you're a policymaker trying to address the digital divide or digital gender divide and you only have data for the entire country, you don't know where to start. Is it in a specific region? Is it a specific user group, age group, educational group? Where do I prioritize my initiatives? So related to the SDGs and national policies, granulating this and segmenting data is a key challenge. Also, the bulk of research, while it recognized the importance of the inclusion of girls and women, it does not necessarily address how to do it. Yeah? Just giving access is not necessarily enough of a conclusion. Also, the lack of geographical segmentations and user segmentation divided by geographical location, income, and educational segments are seen as something that could be built up further. This actually reflects some of the ongoing discussions that we see in the UN institutions related to the SDGs, but also in other regional institutions where, for instance, Eurostat, through its household surveys, are granulating data more. And we see that a number of emerging economies like South Africa, Brazil, are doing similar to try and address the data, the lack of data, and to fill the gaps in order to try and do better policy. Now, again, there is really a need in the literature to look at some of the drivers of inclusion in particular to try and address it, but also, again, maybe to look at more collaborative approaches to data analysis. So also for us researchers to not reinvent the data set all the time, but follow some of the norms we see in the statistical agencies on age group breakdown so it can be compared easy with other things like population data or educational data, and also use sort of geographical locations that we see being applied in statistical agencies to sort of build up more collaborative data collection and capturing. And then again, looking at that in relation to policy frameworks and strategies to address this widening gap. Now, the widening gap is also seen in developed countries during the lockdown, in the lower income groups in European countries, that there is this gap widening, that the ones that are online, they have benefited from that during the lockdown, but those who are not, or those who do not have the skills, have been sort of left behind for the last few years. So there are some issues around that. Now, that is really all I think I have time for. I'd like to thank all of you for listening, and particularly for the
you
online
so much.
audience. If there's any questions, please feel free. Otherwise, our contact details are at the end slide, so you can always contact us by email. Thanks.
Thank you so much. If there is any question for Morten? Yes, please.
We'll share the microphone up here.
Thanks a lot, Morten. It was really interesting. First of all, the question, what really interested me was about how the cultural factors and the geographic factors, that more than the geographic factors, the cultural factors, how it influenced. Can you please explain on that? And one more thing, one of the observations that I've made in my PhD and also in the other 2 papers that I wrote is that developing countries, they really lack research in this particular area. And so most of the references are from the Western countries. So they have usually taken those models, the conceptual models, and tried to like shoehole them in their culture without the, what is it called as, without consideration for the differences in culture, and that's created an issue. So what about some sort of an indigenous practices? What are your thoughts on that? These are my questions.
Okay. Thanks. So two ways to look at that. I personally find looking at, for instance, the race or the religious dimensions as less useful than looking at income levels and educational attainment levels. What we see in other socioeconomic research, anthropology research, which I'm not a specialist in, I must say, but friends of mine studied that, and what you see is that over time, as education and income levels increase, some of these other factors minimizes. Yeah. What we did see, interestingly, about your question around context and local context in relation to frameworks is that often there's cultural dynamics between the genders at play. So there's actually some really interesting research from Johannesburg in South Africa, from the low-income townships, slum neighborhoods around Johannesburg, around free public Wi-Fis, where the masculine culture of boys prevents girls from using the Wi-Fis. They're literally bullying them away, yeah, to sort of capture and dominate the free hotspot. You see some research in low-income neighborhoods in urban areas in Brazil, for instance, and also South Africa, that even grown women won't go to public Wi-Fi areas at certain times of the day because it is unsafe for women. Yeah. So again, here there's a contextual gender angle that is important and gives you that contextual factor. Yeah. I'm not sure if it's the same in the subcontinent, for instance, but in Europe, because of the more advancement, public Wi-Fis are becoming less relevant because every cafe has a Wi-Fi. The libraries, etc. And most people can afford the internet access now. But there is some relevant elements, and trying to take the tested frameworks but adjust them in some of the questions, particularly around educational attainment level, income level. I think the urban-rural divide, even sort of are you a traditional white-collar or blue-collar type background, can be relevant to see how do we use technology, how did India manage to get the 0 rupee accounts and the Aadhaar EID rolled out to rural areas and even to adults which are not literate? Yeah? How do you communicate that value added? And how do you capture that in your research so you can advise policymakers on what works and what doesn't work, I think is my answer to your question, because there is some gaps there. But again, it comes into other elements around digital and service design, about making things simple and intuitive. Government often overthinks user interfaces. So here again, if it is as simple and easy and intuitive to use that someone that is battling with the digital skills or illiterate can actually see the value in it, which we've seen lots of global solutions for, particularly in rural areas on, crop pricing and sales, that people will find a way to use it because they see the benefit of it. We also see in sort of some of the anecdotal experiences coming out of, for instance, Northwestern Europe on digital divide, particularly with seniors, is that there's a lot of people that know how to use technology. They know how to go online for banking and shopping and this, but they know it because it's repetitive. They recognize it. They've done it a million times, but as soon as the user interface changes a lot, they get lost. And then they need support for them to help because the new solution is too complicated or they don't recognize where the functionality is. So again, there's something around also simplicity in design, particularly for those with weaker educational levels or lower digital skills levels. So it's not necessarily gender specific, but because women and girls unfortunately have often less access to education or have shorter educations, they are proportionally more likely to be in those groups because of other factors not related to technology as such, but to educational opportunities or economic opportunities. So I think there's a lot of crossover there. So technology is an important element, but it's not the main element. So I think there's a lot from anthropology and other research. I hope that answered your question. Is there a question over there? No, you're just nodding. Can I ask you a question? I know you're from South America. How do you see digital divide in South America? Is it reflecting the developing economies, or is it more reflecting the Europeans and North Americans?
I think it's more towards the developing economies.
So more the...
Still a lot of inequality, and as you said, well, when you mentioned about the access to internet, which is one aspect,
Yeah.
still, I guess it's not maybe extreme, as you might say, that in a public space women don't go.
Yeah.
But there's still a divide, and not everybody has
Yeah.
access. When you spoke about the digital literacy, it's
Yeah.
very true.
Like-
I can say even from my mom, when it's something on the interface, she's lost.
Oh, it's like my dad. It's like my dad. I've seen him crawl around under his desk at home when he got a 404 error saying, please check your internet connection. And that doesn't mean that it's his internet connection that's a problem. It's the interconnection between the server he's trying to access for his online bank and the general web. So, that's what we're talking about. But interestingly, in Latin America, a number of social security authorities were discussing or have even, during the pandemic, made certain IP addresses free of charge. So they've made deals with the telco saying that government IP addresses can be accessed for free, so it's not charged on your mobile phone or your data subscription. I think Ecuador had some tax rebate, so VAT was cancelled on mobile phones, laptops, routers, but only because of COVID. Yeah, so it was very limited. And those are maybe some of the policy recommendations that can come out of research around the gender divide. How do we actually facilitate affordable access or non-discriminatory access by being creative around our auctioning of telecom licenses, of certain IP addresses being free of charge to ensure that people have remote access to education or to government services. So it doesn't come out of their data pack. Anyway, thank you very much.
Oh, thank you. Don't know if there's any other question. Thank you so much. Let's move on with the next online presentation from Izabela Kapsa and Magdalena Muzial-Karg from Poland, the Internet User's Opinion on Public Services and Empirical Analysis. Let's start, please, the video.
On the Internet users' opinions on public e-services, which is connected with the research program. The research problem is the public services as one of the most dynamically developing areas of the state functioning, which is confirmed by the systematically increasing number of e-services and the users in the individual countries. Moreover, we observe that the COVID pandemic has had a significant impact on the functioning of the entire international community, also in the public sphere. And the consequences of lockdown and the dictation of social isolation and distance transferred many human activities and institutions to the internet. Due to the dynamic development of e-government in recent years, the rules introduced during the pandemic have become an essential stimulus for providing an extension of public services to be realized via electronic tools. Also, citizens, owing to the impossibility of using administrative service traditionally, were mobilized in a way to deal with matters exclusively via internet platforms. In Poland, for more than 25 years, had been gradually employing ICT in public administration services, and also the most significant number of people using e-government services was recorded in 2020 during the COVID pandemic. Due to epidemic restrictions, citizens could deal with more official matters via the internet. So, having the results of our study and the survey conducted in 2018, we would like to show or verify the hypothesis, assuming that polls, declaration and opinions on electronic public services correlate with the time spent on the internet. And the issue has been presented in the form of an analysis of empirical data regarding polls' experience and opinions on electronic administration tools, especially in the context of internet usage, and statistical data regarding e-government development in Poland. And that's why I would like to start with the information on the state of public e-services in Poland. Because digital public services are one of the significant dimensions of e-government, and according to many definitions, e-government refers to the use of ICT by government agencies to improve the delivery of information and public services to its citizens through transparent and accountable means. And the idea of e-government appeared in Poland about 25 years ago, and the development of electronic undertakings implemented by the Polish government was closely associated with the integration process. Before the EU accession, Poland had to fulfill a number of conditions, including some related to the implementation of e-government solution. And then the concept of e-government was explicitly referred to the Information Society Development Strategy, and also currently it's based on the documents that indicate direction for evolving policies and services. So basing on this, we can compare the level of developing e-public services in Poland also to the other members of EU. According to the statistics in 2018, 81% of Poles aged 16-74 use the internet regularly, at least once a week. In comparison, it was 78% in 2019 and 74% in 2018, so we can see that this level is growing up, but still not so, it's not so high than the rate in the European Union, which in 2018 was 87. In table 1, we present the public services available via internet in Poland in 2018. And we can see that there are many websites, service offered via internet, in the area of civic matters, in the area of work, of enterprise, and the taxes. So that was on the state administration, local administration, the main services available online. In table 2, we present the individuals using e-government services in the last 12 months. And the individuals used government services in order to obtain information from the websites, download official forms, or submit completed forms. We need to add that even though many services classified as e-services, they are not entirely digital in practical terms. In certain situations, a visit to the office to collect a document or put a signature was necessary, and only a form could be sent over the internet. A showcase example, and at the same time one of the first e-services offered, is the payment of taxes. For several years, mandatory annual tax returns can be filled through a computer program which calls e-deklaracje, e-declarations. Since 2019, an electronic version of the tax return is developed by the Ministry of Finance and available fully online. Looking at this table, we can see that in 2020, the percentage of people obtaining information from websites of public authorities increased by 2.3 percentage points, and those sending completed forms by 2.1 percentage points compared to the previous years. So the data show that the share of public administration e-customers has increased each subsequent year, regardless of the type of the activity. However, it's worth noting that Poland's progress does not look so optimistic compared to other countries. In the latest report containing the Digital Economy and Society Index, Results Digital Economic and Society Index, Poland was ranked 6th from the bottom of the 28 member states of the European Union. Such a low overall result for Poland was significantly lower than the European average for 4 out of 5 area indicators: human capital, use of internet services by citizens, integration of digital technologies, and digital public services. Only in terms of connectivity, Poland achieved a result slightly higher than the average for the entire group. The position of Poland is slightly better compared to the United Nations member states. According to the e-Government Development Index in 2020, which presents the state of development of electronic administration, Poland ranks 24th out of 193 surveyed countries. Compared to the report 2019, Poland moved up 9 places, but it's still lagging behind most European countries. When it comes to the position of Poland against the background of 42 European countries included by e-Government Development Index, Poland ranks 60th among the European countries. In this part of our presentation, I would like to present the research results on Poles' opinions on the public services. And the study that we present here was conducted between April and June 2018 through Poland. The sample of respondents numbered 1,716 Poles and was selected in quota manner, taking into account the demographic characteristic of the population. Then, according to the sex and age, the sample size concerning the population was determined. After meeting these criteria, the subjects were selected using the snowball method, and most of the respondents chosen in this way completed the paper version of the questionnaire. It was also possible to use the electronic version, available to all network users. Among all the questions asked and the statements made in the survey, in this presentation we only present the average result of responses to the statement relating to e-government and public e-services, taking into account the relationship between the answers and the time spent on the internet every week. The research result on e-services, in the opinion of Poles, are based on the two statements that refer to their experience with e-services and their declaration to use them more often if possible. The empirical analysis is based on answers given by respondents to the following statements included in the questionnaire. I use electronic administration services. Example, I send documents to institutions over the internet, send emails to authorities, send my tax returns via internet, etc. And the second one, I would like to have more opportunities to deal with official matters over the internet in Poland. The answers were expressed by using the Likert scale, so the respondents could choose 1 out of 5 possible options. Definitely yes, rather yes, hard to say, rather no, definitely no. While processing results, each option was coded in numbers as follows: definitely yes 5 points, rather yes 4 points, hard to say 3 points, rather no 2 points, definitely no 1 point. Information on using the internet was obtained from the question: how many more or fewer hours a week do you usually spend on the internet? The answers of the respondents were arranged in a cafeteria containing 7 categories. 1. I don't use the internet. 2. Up to 2 hours. 3. From 2 to 7 hours. 4. From 8 to 21 hours. 5. From 22 to 35 hours. 6. 36 hours and more. 7. It's hard to say. The primary descriptive statistic presented as percentage of answers show that for the first statement, nearly 70% of respondents answered yes, and for the statement 2, nearly 80% of respondents answered yes. So we may argue that they expressed the expectation towards public services to be provided online, because if someone uses e-government services, they would like to have more such services offered. The result of the analysis of respondents' responses to the first statement using the Kruskal-Wallis test was statistically significant. John-Sidak post-hoc test showed a significant difference between non-used internet users and all other groups, and between the hard-to-say group and groups using internet up to 2 hours weekly. There was also a difference in the statistical trend between the hard-to-say group and the 8 to 21 hour group. The other differences were not even close to the statistical significance. Regarding time spent on using the internet and the opinion on the statement "I use electronic administration services," 3 groups recorded the highest average result of responses to this statement: people using the internet more than 36 hours weekly, people using internet 35 hours, and hard to say. The lowest result was recorded in the group of non-users. Also, the result of the analysis of respondents' responses to the second statement was statistically significant. The Thun-Sidak post-hoc test showed a significant difference between the following groups: non-internet users and all other groups, people using internet up to 2 hours weekly, and people using internet between 22 to 35 hours, people using internet between 8 to 21 hours and hard to say, and more than 36 hours. And the third group was people using internet 3 to 7 hours weekly, and group hard to say, and more than 36 hours. And regarding time spent on using the internet weekly and the opinion on the statement "I would like to have more opportunities to deal with official matters over the internet in Poland," the highest average results for this statement were recorded in the 3 groups. People using internet more than 36 hours weekly, people using internet between 8 and 21 hours, using internet 22 to 35 hours, and hard to say. Again, the lowest result was recorded in the group of non-users. In each group, however, this result was higher than in the previous statement. To conclude our research, we need to say that the public e-services are one of the most dynamically developing areas of the public administration functioning, which is confirmed by the systematically increasing number of e-services and the users in particular countries. In Poland, dynamic development of this sector of public activity has been observed for many years, which is confirmed by international rankings, including the e-Government Development Index. 2020 was an exceptional year in this respect due to the pandemic that continued as an accelerator for the increased interest of citizens in using public services provided via the internet. Answering the research question, we state that Poles use more and more public e-services year after year. In last years, they use it mainly to obtain information from websites of public authorities, download official forms or submit completed forms. As the results of the survey show, Poles want to use more e-services and deal with official matters via the internet. Almost 80% of the positive answers. Moreover, people spending more time on the internet are more likely to use and better evaluate e-government. So the hypothesis has been positively verified. There have been statistically significant differences between people who do not use the internet and all other groups to use e-government services. The general conclusion from this survey is that Poles would like more services to be provided electronically. The more they use the internet themselves, the more services they would like to do this way. The more they use public e-services, the more citizen activities they would like to take electronically. Since Poland's results compared to other European countries indicate the necessity to take measures to develop this area of state activity, it is crucial information both from the point of view of research and practical implications. Thank you very much for your attention. If you have any questions to ask, please send us emails with your question and we will reply to you. Thank you very much. Hello everybody.
Problems with the UI. If there are any questions, I suppose that you can express them to the hosts so that they can send it to the authors.
I was just chatting with one of the authors on Facebook.
Okay. So I guess that any questions have been answered in real
We
life.
would like to share with you the
just move to the next one. As we switch, the next one is a paper from
Hello everyone. My name is Alandri.
Okay. Alandri, Antonio Alberto Texeneta, Tatiana Cavallo, Danos Cavalcanti, and Tarladi, of course, Severo Leita da Silva. The paper is called The Digital Divide and the Smart Digital Governance in Brazil, Tensions Between the Skills of Multiple Policy Areas and the Needs of Society. Shall we press play, please? Thank you.
Hello everyone. My name is Alandri. I'm presentation my study now. All right. Thank you. My study is namely the digital divide and the smart digital governance in Brazil. Tensions between the skills of multiple areas and needs of society. My name is Alandri Severo, and it's my co-authors Antonio Alberto and Tatiana Carvalho. Contextualization national of discurso técnico of reporting studies for important national work organization that adopt on the information technology communication can contribute to grow, development, and overcome the various difficulties. Resist, have a present, the digital divide has a reality and responsibility that goes beyond being connected and disconnected. Study objective, this study aims to provide an overview of the tensions between the competence and multi-political domains and some of the needs of society and that contribute to digital divide and demand efficient practice of smart digital governance in Brazil. Introduction, speed of release and reorganization important that ICT can have studies, have a certain prevalence of resist the aspects are individuals and companies, interactive communication, business, all right? However, as relevance is truly relative in the time, since the digital divide suffer the mismatch that goes beyond the relation between the adopted and used technology. Search has corruption, deficiency in the education, absence and deficiency, integration, and social, economic, and environmental responsibility. In contrast, successful cases with a more social, collaborative, sustainable, and civic inclusive scope have been identified and defined and studied in the literature has smart digital governance. For example, models of this smart digital governance are really and begin developing the significant results in South Korea, New Zealand, and Australia. Literature review new artifacts, perspectives, and categories of IT, information infrastructure, II, gain great attention in the years. And the class studio, cited in the reference. In summer, information infrastructure is a shared, involve open, heterogeneous social technical system, essential for form-based, style-based IT capability and respective operation using in the developed community. The formation and development, growth, scalability, and consolidation of information in infrastructures is permitted by tensions. Conceptually, tensions are the main research and barriers that contribute to developing balance and sustainable of information infrastructure. The identification of tension is not the prerogative for technological analysis, but the result of collaborative work, technical and social, with the various actors and their relationship. Such an objective, this is smart digital governance and digital divide from the world to Brazil. Coming from the private sector and with the objective of making the state more flexible and moment the increasing globalization, internationalization. Practical search has responsive governance, new public management, or digital age governance. In more recently, smart digital governance area on the agenda of governments and scholars around the world. Smart digital governance, considered as a member of the last generation of digital governance. First, has smart, sustainable, predictive ecosystem centered, engaging innovation, and focus on the service delivery among the workers. Because according to the digital maturity model, such smart brings the mark of different characteristics of values, service model, platforms, ecosystem, leadership, focus in technologies, and key metrics of their predecessor. In smart digital governance, the governance culture is more innovative, collaborative, and social, the accord of the authors. Estimated that adoption of smart digital governance will be more sustainable and will string of posterior the democratic values that connect the demand of the publicness for various servers. Okay? These studies conducted between 2017-2018 empirical investigation with 8 government agencies and analyze their respective governance documents and online materials regarding the extent of change and effects in the implementation of self-orientation electronic government initiatives, concluding that there is a need for better fit between technology system and social system. In addition, analyzing the student by these authors, political, social, technology, and organizational issues support the challenge already posed. In South America, more precisely in Brazil, this student point out the value at the current national digital government initiative and the reality of digital divide. Are a consequence of an efficient structure, lack of government structure, deficient infrastructure, and effect cascade effects. One indication of what was description was cited for this author. According to the author, the sanitary emergency generated by COVID pandemic double government infrastructure technology inefficient can produce negative impact of digital divide. Other server, the information communication technology in Brazil, in interview households, record that the COVID-19 pandemic made ever more evident the digital divide of significant portion of population, which persists in the context of inequalities and access, digital skill, and ability to carry out activities and take advanced remote and online. Cultural opportunity, school and academic research, courses and train, remote work, and government service available. Among others, authors, some of the students that digital divide involving research among small and medium-sized companies. Digital divide has a found relatively low production and high mortality rates of these organizations. Other students discuss the digital divide from perspective of education, culture, and are present in Brazil. The discussions about the vote electronic system in the order social program in Brazil. Therefore, when look at the world in Brazil, in observation the relative tension between digital governance and digital divide, their complexes and heterogeneous allow them the permanent and dynamic and aspect relationships in interactions. Applied fundamentals defend the related to information infrastructure as an efficient strategy capable of factoring and responding to sustainable process of implementation. As an information infrastructure is resilient to the variations of present conflicts. As I was already observed from the scientific experience mentioned, polarized solution of digital governance general tension that are the main source of ground learn and evolution of infrastructure. In your study, research method use a framework for study the stress and stability based on how influence the establishment of information infrastructure. Results observed the digital government in Brazil from the perspective of information infrastructure. Tensions can need to see balance and see what one smart digital government that attend the need of society and avoids the digital divide in Brazil. You can see tension local global evidence this tension and the authors, individual and collective evidências in studies, técnico social. You can see characteristics described because the time I need to finish. Hierarchical and matrix evidence in these studies, a short time and long time. You can see evidence in this study too. The author is on some studies and research the area of the electronic government in Brazil. This indicator of the studies, city here, analysis are showed in general, current digital government project in Brazil, track for centralized hierarchy practices or rigid approach to expand service to citizens. Infrastructure alienated from needs, deficient, limited, and unknown to consolidate itself globally. In Brazil, use the information technology of the government is not size that are unitary, singular, disconnected, rigid, top-down, closed, single-centered, dependent, fixed contracts, static, mechanical practice. Brazil has created on the tip of a government which is not sustainable, right? Focus and technical and automatic aspect, not involving. However, a transformation to successful smart digital realm is one possible when a more comprehensive performance, including the definition of strategic objective and goals based on information infrastructure theories first adopted. Conclusion, the panoramic constructed in the present students showing that the case in the Brazil, the current practice for the construction of electronic government projects do not meet the required and the event sustainable. Brazil governments and government issues we modernization the technological infrastructure and workflow. The focus is purely techno. The digital government program offer many serious changes in the interaction in society and government. Its objective has not resolved the problem in efficiency, corruption, freedom, democracy, evolution, health, security. Now the reference. Thank you. This is my contact. All right, thank you. It's my email. Thank you.
Okay, pressed pause successfully this time. Once again, if there are any questions that we can forward the authors, please send it to us. And the final presentation from Francois van Schwalkwijk and Michael Canares is entitled Public Procurement and Social Inclusion in the Network Society. Okay, let's press play.
Good afternoon, everyone, and greetings from Cape Town in South Africa. I'm glad to be able to join you today. Special thanks to the organizing committee for allowing us to present in this format. Otherwise, we would not be able to participate in the conference. And I'd also obviously like to acknowledge my co-author, Mika Canaris from the Philippines, who is also unable to join us today. I'm going to switch over to presentation mode to work through a few slides with you. I hope you find it interesting. Thank you. So hopefully everyone can see my screen now. By way of introduction, I'd like to emphasize the fact that we're looking at a particular area in public procurement reform, referred to as open contracting. In other words, the publication of open data related to contracts issued by governments often with the intention of bringing in new actors, particularly those previously excluded from large contracts, to distribute the benefits. Our starting point is that there remains a need for more robust evidence to support claims that public contracting reforms have led to the increased use of data and have resulted in beneficial outcomes. Seldom is evidence used to test or develop theory. That is our understanding of how, why, and under what conditions initiatives succeed or fail. Furthermore, little is known about the specific outcomes of reforms such as open contracting, including whether it results in greater social inclusion. And of course, we need to be fairly specific about what we mean when we refer to social inclusion, and we borrow a definition from Ruiz 2020 that you can see on the screen there. This particular paper aims to identify and assess how key aspects of public contracting reforms have led or not to increased inclusion. The focus is on developing countries where we think inequality and exclusion are the most pronounced. We use a particular conceptual framework from previous work that we've done, mainly on open data, and we applied in the context of open procurement. We believe that a conceptual framework that does not account for the exercise and disruption of power is unlikely to produce insights that are grounded in the realities facing marginalized communities in their struggles to be included in the decisions that shape the quality of their lives. We can't assume that by making contracting data and processes more open, that there will automatically be any real lasting impact, unless there's also a change in the power dynamics that led to that particular change or outcome. This conceptual framework therefore not only accounts for power dynamics and how they shape the inclusion or exclusion, but takes account of different types of power in a society that is increasingly shaped by global networks. Social actors can also challenge existing power structures and networks through what Castells calls counterpower. Counterpower in the network society exerted when social actors attempt to change the programs of specific networks and or disrupt those who represent the dominant programmatic logic of that network. In the conceptual framework, we identify a set of antecedent conditions, factors as they're called here. These are opportune niches, intermediaries, value creation, disruption of data flows, value activation, the presence of switches, which then in combination of various types may lead to either inclusion or exclusion. We don't present these in a linear kind of format because we believe that these factors may activate in different orders, in different contexts. It's also possible that some may be activated and others not, and that may be sufficient for change. It might all really depend on the context. What we mean here by each of these, I don't really have time to go into them in great detail, they're outlined in the paper, but when we talk about disruption of data flows, we often refer specifically to open data, where data that was previously not accessible, and only accessible to some, that could protect their own interests and maintain information asymmetries, are disrupted because data is now more universally accessible. That has the potential to disrupt the existing data flows. At the same time, these new sets of data may create opportune niches in the system or in the network. These niches are openings that attract new actors into the network to provide services or to connect other nodes in the network. And these may have particular impacts on the network. These may be intermediaries, the actors that enter these opportune niches, intermediaries that connect various other nodes or actors in the network. And what's really important about these intermediaries is that they may, in some instances, or we can't assume that they will always do so, they may create value from the data that's available to some that are either outside the network or others inside the network. So that's the process of value creation. So data that may be accessible but has little value to others because they can't understand it, can't use it for their own needs. Intermediaries may often work on that data to make it understandable and usable. Now, through that value creation process is very important. That value needs to be activated in other networks. So value needs to be extended across networks. This gets a little bit more complicated, and as I said, you can read more in the paper, but our assumption is that if value is activated in, say, the NGO or Global Development Network, to describe it as such, that doesn't necessarily mean that it's going to be of value in a different network, in, say, the global financial network or political network. So when the data has value in both networks, then there's more of a potential to threaten or change power relationships in the other network. I'm going to move on from this now, as I said, for the sake of time, although it is important. We have 5 case studies that we looked at. Not all of them are in the paper. The top 3 are. The bottom 2 you can find in a report, which I can share with you. In this particular presentation, I'm going to really focus only on the Philippines case, again, for reasons of time. So the case of Banda Kita in the Philippines, I'll go through that fairly rapidly to try and show how some of these antecedent factors come into play. But based on the Philippine Constitution, the ownership of minerals is vested in the Philippine state, but are open to contractors on the basis of revenue sharing. Revenue sharing is governed by the provisions of the Local Government Code of 1991, which prescribes that local governments are entitled to a 40% share of the annual gross collections. In the case of mining activities on the ancestral lands of indigenous people, a minimum of 1% of the market value of gross output is to be paid by the mining companies as royalties to indigenous peoples. The royalties may be reduced after certain costs incurred by mining companies, as prescribed in law, are deducted. Banda Kita, or BK, a national coalition of civil society organizations headquartered in Manila, implements the Open Mining Governance Project in the Philippines. It aims to facilitate knowledge sharing and lobby duty bearers to improve mining governance. In 2015, BK's project, which aims to increase the use of mining data, was initiated, mining contract data, sorry. BK identified this opportunity because of the large amount of data in the mining sector that government had published after the country institutionalized a global standard for the governance of extractive resources, that is, the Philippines' EITI. However, BK observed that capacity among CSOs and communities to access, understand, and use data was a challenge. In 2018, BK began to focus on the community of Bataraza, where Rio Tuba Nickel Mining Corporation operates on indigenous peoples' ancestral lands. The project worked with indigenous communities to better understand publicly accessible mining data. This included data literacy training with its local partner, the IPDO, with the support of the Palawan State University. BK also facilitated the preparation of knowledge products that explain how royalty payments are computed, including the legal basis for the computation. BK used these knowledge products to explain to IPDO the royalties they can rightfully expect to receive. Realizing that what IPDO received from Rio Tuba was lower than what their computation suggested, obviously using the data that was now available to them, a meeting was facilitated between IPDO and Rio Tuba to discuss the discrepancy in the royalty payments. It became clear from these engagements that the variance in the royalty payments was attributable to a 20% withholding tax deducted by the mining company from the royalties due. This deduction was confirmed as legitimate by the Bureau of Internal Revenue at a roundtable discussion. After the findings had been agreed upon by both IPDO and Rio Tuba, feedback was sent to the Philippines EITI. One of the lessons for BK was to refocus its advocacy towards the exemption of royalty payments from withholding taxes, so that more benefits may accrue to indigenous communities, which is an ambitious undertaking as it requires revisions to the tax code and a loss of revenue to the state. So IPDO's ability to access and understand mining data has been instrumental in its ability to engage and negotiate with mining companies. As BK reported, the different value creation activities that enabled IPDO to access and understand mining data led them to raise questions and engage successfully with Rio Tuba on royalties owing. With the assistance of BK, the indigenous community was also able to engage in dialogue with the National Commission on Indigenous Peoples and to push for a tax exemption on indigenous communities' royalties. The different activities facilitated by BK empowered IPDO, as evidenced by their ability to ask sharp questions clarify the understanding of the royalty payments and dig deeper into how mining companies fulfill their responsibilities under the law. This realization cascaded to other CSOs working with indigenous communities. While the process did not actually result in an increase in the royalty income for the indigenous community, it did establish a degree of trust between the various stakeholders responsible for ensuring that indigenous communities benefit from the mining activities on their ancestral lands. The process enabled dialogue between IPDO and Rio Tinto to clarify royalty computations as well as to get assurance that they are correctly computed. At the same time, the process provided a venue for collaborative discussion among IPDO, mining companies, and oversight agencies about indigenous people's rights and a future tax policy agenda related to mining royalties. So that was quite a mouthful. I hope you are able to follow. Here I'm just sharing with you a table that shows all the cases and how they were analyzed as per the antecedent conditions that we presented earlier. And as you can see from the table, the Banda Kita was what we would regard as a successful intervention in terms of social inclusion, not so many of the others where many of the antecedent factors were not met and we believe did not lead to any kind of meaningful social inclusion as a result of those interventions. A few concluding thoughts. We start with a case analysis of Banda Kita. There were, we believe, enabling mechanisms that made possible the outcomes described in the case of Banda Kita in the Philippines. First, the country's membership of the EITI provided the overarching framework for disclosing data related to the mining sector. This was supported by legislation that safeguards indigenous people's rights to their share of mining revenues. Second, BK's role as a civil society representative of the EITI leadership places it in a relative influential position to ensure that transparency of mining revenues remains higher on the EITI's agenda. Third, given the stagnant nature of open data initiatives in the country, the push for EITI portal as the primary data source without having to resort to filing a freedom of information request became more critical. Finally, the need to show use cases for published data became urgent to convince stakeholders from within the government that there's value in data publication. These different push factors hasten the disruptive nature of the data published. This disruptiveness of the data was further boosted by the fact that the intent to publish on the part of the government was matched by demand, as indicated by the desire of indigenous communities affected by mining activities on their land to understand the nature of the royalty payments. What is critical, though, in this data value chain is the role of BK in facilitating processes of awareness, access, capacity building, and stakeholder consultation. BK played an important role in both value creation and value activation as a switcher between the social, in other words, the community, and capital, in other words, the mining networks. It made use of its position in its network and established connections to new networks to exploit resources and assets, to promote data use. It engaged trusted local intermediaries, such as the State University, to ensure local ownership and to build the capacity of IPDO to understand the data and to translate complex data sets into usable information. It was able to broker meetings with the mining company and other agencies to discuss the implications of the data. BK also facilitated processes rather than taking the lead in meetings it set up with mining companies and other stakeholders. This facilitation effort did not only make the process more inclusive, but empowering and also more sustainable. Just to wrap up, the BK case shows how governments introduce specific legislation to ensure the accrual of benefits from economic activity directly to marginalized communities. Law ensured that indigenous people benefit financially from mining activities on their ancestral land. Government has created opportune niches in the mining sector specifically for the benefit of marginalized communities. In network terms, the government, as the most powerful actor in the national political network, is attempting to intervene in the global financial, economic network where large mining companies operate. The success of this intervention is not guaranteed, however, because the global financial network will respond to any intervention or interference by defending its own interests, particularly when such an intervention seeks an equitable distribution of wealth and is therefore not aligned with the central program of the global financial network, that is, the accumulation of surplus. Access to public contracting data is important to marginalized communities because they hold the potential to empower those communities to challenge the defensive actions of powerful actors in global financial networks. BK added value to the data, and at the same time, the data was of value to the mining company concerned because it challenged its royalty payments, thus posing a possible threat to its legal compliance procedures. On this basis, BK was able to facilitate dialogue between the community, the mining company, and government to resolve a concern pertaining to the distribution of wealth to the local indigenous community. This research has drawn attention to antecedent contextual conditions created by greater openness and to the need to take into consideration the inherently exclusionary effects of networks. Based on the case studies, that's all 5 of them, open contracting did not lead to the inclusion of marginalized groups as beneficiaries of public contracting. In a single case, though, the one presented today, where a trusted and established intermediary facilitated a flexible and inclusive process, focusing as much on the needs and capabilities of a marginalized community as on the availability and usefulness of the data, the outcome was positive for the community. In other cases, the open contracting data published did not match the need of the communities, and the available contracting data failed to support legislative interventions introduced in those contexts to increase the participation of these communities. Nor were intermediaries or switchers sufficiently attracted by the data to work with communities to challenge those existing power configurations. And with that, thank you very much for your attention.
Okay. Once again, I don't know if we have any questions for the authors. Please forward them. In all cases, this concludes today's session. Thank you so much. And I wish you a very pleasant stay in Athens. And I truly hope that the circumstances in the future will be better so that we can have back the conferences that we're all accustomed for and network as usual. So once again, thank you so much and wish you the best.